As noted in the earlier lecture on the distribution of human genetic variation and the genetic race hypothesis being rejected in humans, in part, this is because, on average, alleles that are common in one population are typically common globally, and alleles that are restricted to one geographic region, such as Africa, are also typically rare in that population. For example, if we find an allele that is only found in Africa, and you happen to be African, you likely don't have that allele. If there's an allele that is only found in Europe, and you happen to be European, you likely don't have that allele, etc. That said, we do find rare deviations from this general pattern of human genetic variation. And these deviations are often very relevant for understanding human biology. The most obvious deviation is skin color. Cultural perceptions of race often include skin color. Skin color does have a strong genetic factor. On average, Africans will tend to have similar skin color genetic traits with each other than they do to most other areas of the world. But this is a very rare exception to the general rule about human genetic traits. But it's also misleading. For example, if we look at skin color globally, we see that using African as a proxy for darker skin would neglect a large number of native people both within and outside of Africa. Moreover, the genetic aspect of skin color reflects a very small part of the functional human genome. It does not reflect the pattern of functional genetic variation more generally and more globally. Nevertheless, finding these exceptions to the rule often provide the basis for the practical importance of human evolution research. These exceptions occasionally happen for major genetic drift events, where an allele that was previously rare won the chance lottery and happened to increase in frequency in the population. But such extraordinary genetic drift events are also extraordinarily rare. As noted in the population genetics section of this class, the other possibility is that this particular genetic type is under natural selection. This is certainly the case for skin color. For example, when controlling for sunlight exposure, light-skinned people have a 10-fold risk for skin cancer. In fact, skin cancer rate among native African albinos is estimated to be a startling 23%. Clearly, this will have an enormous selective pressure on a population. Darker skin in these high UV areas will be of an incredible reproductive advantage. Thus, it should not be surprising that 200,000 years ago, when all humanity lived in Africa, they also all had dark skin. Light skin evolved much later. Now, very dark skin can be too protective of ultraviolet UV light in areas that receive less intense sunlight. Exposure to UV radiation permits your skin to produce vitamin D, which helps maintain a strong skeleton. During the peopling of more northern latitudes, where the sun is less intense, there appears to have been at least 2 separate events in which natural selection favored lighter skin tones. One event contributed to the European skin tones, and one event contributed to the Asian skin tones. Today, technologies such as protective clothing and sunscreens and fortified foods have largely removed these selective pressures in wealthy countries, but they remain an important consideration in developing countries with less access to these interventions.